Number 61. A piece of metal of mass m kilogram has 5 kilogram removed from it. 18 kilogram remained. Which algebraic expression can be used to find m? There is no problem understanding that if the mass is m kilogram and 5 kilogram is removed, then the result is m minus 5. If you take away 5 kilograms, it's just as well you take away 5 kilograms also in your mathematical statement. So m minus 5. M minus 5. It says also that 18 kilograms remained. Therefore, the result is 18. Of course, no problem. M minus 5 is equal to 18, and that is represented by option A. We have an equation. Let us solve it as a revision of some of the principles applied in section C. 5 is subtracted from m. So let us add 5 to both sides of the equation. Remember that if we are subtracting 5 here, what do we do? So the result is equal to 18. We have an equation, so let us solve it as a revision of some of the principles applied in section C. 5 is subtracted from m, so let us add 5 to both sides of the equation. So because we are subtracting 5 here, we need to eliminate the 5. We are going to do what? Apply the opposite of subtraction, which is addition, to this side. Because we are dealing with an equation, what we do to one side, we have to do to the other. So we need to add 5 to both sides. By the time we have done that, what will happen? These 5s, what special names are given to these figures here? Negative 5 plus 5. They are additive inverses. And in an equation, they are going to eliminate each other. So m is going to be left as the only symbol on the left-hand side. On the right-hand side, we have 18 plus 5. So let's see that. Negative 5 and its inverse plus 5 are eliminated from the left-hand side. And the overall effect is that 5 is added to the right-hand side. So m is equal to 18 plus 5. And of course, the solution does not require that we simplify the right-hand side. The answer is therefore option C. If 6k minus 5 is equal to 25, what is k? That's a little bit more sophisticated than what we have had before. K is on the same side with 6 and the negative 5. We first get rid of the negative 5 by adding 5 to both sides. The overall effect is that 5 is added to the right-hand side. Remember, we have done this quite a few times, so we should at least be familiar with it right now. We have a negative 5 here. We are going to apply its opposite on the left-hand side. Therefore, we need to do the same thing on the right-hand side. On the left-hand side, we will have additive inverses, so the negative 5 is going to be totally eliminated from that left-hand side. So we have now 6k is equal to 25 plus 5. And of course, what is 25 plus 5? 25 plus 5 is equal to 30. So 6k is equal to 30. And as we have seen in a previous solution, we have 6k. What does 6k mean? 6 multiplied by k. So in order to eliminate that 6 from the left-hand side, if it is being multiplied, what do we do? Subtract? No. The opposite of multiplication is division. So we are going to be dividing by 6 on both sides. So 6k means 6 multiplied by k. We therefore need to do the opposite of multiplication, which is division. So we are going to divide both sides by 6. This will cause the net effect of dividing by 6 on the right hand side. So k is equal to 30 divided by 6. And what is 30 divided by 6? So k is equal to 5. And that is represented by option B. Sometimes our questions have two numbers that we need to transpose to the other side. That means, like this problem here, we have a 6 and a negative 5. We need to get rid of that 6 and that negative 5. The rule governing the order in which we transpose is that we transpose the one that is the least related to the unknown first. So we have two things here that are related to the unknown. The unknown is k, the negative 5 is related to the k, and the 6 is related to the k. But we need to get rid of the one that is the least related to the k first. Notice that 6 is more closely related to the unknown than 5. We therefore eliminate the 5 first. And that is why in this particular case we have added 5 to both sides first. If x is equal to 5, y is equal to 4, and z is equal to 6, what is the value of z minus all of x minus y? The reason why I say all of x minus y is that if I read this 7 minus x minus y, it does not give the impression that x minus y is an entire entity that is enclosed in brackets. So let us write down the expression as it is there. Good. Character by character. And then what do? Where we see, which one are we going to eliminate first? Are we going to substitute the x first? Let us do our substitution by first replacing x by 5. X is gone and 5 takes its place. Why? Because x is equal to 5. Replace y with 4. Y is equal to 4. And of course, replace z with 6. Z is equal to 6. Simplifying the expression by first, we're going to simplify the expression by first performing the operation that is in the bracket first. During simplification, the operation in the brackets should be executed first. So we have our 6 right there as it was before, and 5 minus 4 is equal to 1. And then 6 minus 1 is equal to 5. The answer is therefore option D. 5 blue beads, 6 red beads, and 1 white bead are in a bag. What is the probability that if 1 bead is chosen, it will be blue? I remember some time ago, they used to ask this question, how many blue beads make 5? I hope that's not too much of a difficult problem for you, Jerry. Now we have 5 blue beads, 6 red, and 1 white in a bag. And what is the probability of choosing a blue? The formula used to calculate probability is given below, and we are going to be using this all the time. Probability is equal to total number of events that will give a favorable outcome over the total number of equiprobable events. What does that mean? All of the beads have equal chances of being selected. So the total number of equiprobable events is equal to the total number of beads. So each bead has an equal opportunity of being selected. So the equiprobable events will be the total number of the beads. And we have them 5 plus 6 plus 1. And that is equal to 12. Now what about the total number of events that will give a favorable outcome? What will give a favorable outcome? We need to select a blue bead. So any blue bead will give a favorable outcome. How many blue beads do we have? We have 5. The probability may be found by dividing 5 by 12. So 5 is the total number of events that will give a favorable outcome, and 12 is the total number of equiprobable events, so we will have 5 over 12. Probability is equal to 5 over 12. The answer is option A. Mandy scored 87, 85, 82, 71, and another 85 on her 5 algebra tests. What is the modal score? Let us write down the numbers as they are given. The best initial step to take is to arrange the data in order. This process is called sorting. The order may be ascending from small to large, that is ascending going up, increasing, or descending from large to small, getting smaller each time. So let us sort them. Identify the smallest one first. So that's what we're going to do. Right, and we're going to write it down. Then, of those that remain, choose the smallest one. Again, we choose the smallest one from those that remain. We have 82. Of course, next in line we have 85. And we have 2 occurrences of 85. So, let's put both of them there. And then, of course, 87 is the one that will go next. And of course, last. It's the largest number, as a matter of fact. The mode is the one that occurs the most times. 85 is the one that occurs most times. As a matter of fact, 85 is the only one that occurs more than once. It is the one that occurs the most times, so it is the mode. And that is represented by option B. And of course, we have that same problem with Mandy scoring all of these on her algebra test. What is the median of the set of scores? That's the question. What is the median? The median of a set of scores is best found after they have been sorted. So we sorted them on the last slide. So let us rewrite the sorted list. So we have them sorted already from the last slide. So we're just going to write them back. The median of a set of score is the middle number. Most students will not have a problem looking at the data and picking out the one that is in the middle. However, if we simultaneously strike off numbers from each end, it is easier to see that the one that is in the middle is going to be 85. So let us strike off simultaneously one from each end, strike off another pair, and there we have it. The one that remains is 85, and the number that is left is the one in the middle. 85 is the median, and that is represented by option B. A box contains 8 red chips, 1 blue chip. What's the probability of selecting a blue chip on the first try? That is another probability problem. And of course, we know our nicely worded formula that we need to determine the probability. Total number of events that will give a favorable outcome over the total number of equiprobable events. Alright. So all of the chips have equal chances of being selected. the total number of equiprobable events is equal to the total number of chips. How many chips do we have? 8 plus 1, which is equal to 9. We need to select a blue chip. Any blue chip will give a favorable outcome. Therefore, the number of events that will give a favorable outcome is 1. So the probability may be found by dividing 1 by 9. So total number of events that will give a favorable outcome? Only 1. Total number of equiprobable events? All of them together will be 9. So it is going to be 1 over 9. And that is represented by option D. The table shows the average grades scored by students in a class. Which type of graph would best represent this data? The answer is option A, double bar graph. Why? Why this double bar graph? Well, let's see if the computer has any set of arguments for us. A graph is of no use if it only shows the data. The type used must be suitable for the data given. It should be chosen because of special features of the data. And it should also be chosen because what? Of the type of data given. The average grades of the students are separated into 2 categories. Because of this fact, a graph that will depict the 2 categories should be used, preferably one that will allow us to compare the grades of the boys and girls. The double bar chart with a bar for boys and 1 for girls, shaded in different ways, will allow us to do this. A pie chart does not allow us to depict 2 categories of information quite easily. This choice, along with choice D, a pictograph, would be a disaster if they were chosen. If the number of lines were specified, say multiple or double, the line graph would have been the most appropriate. The lines, by showing the information related to boys and that related to girls, could have been shown by different colors. It would have been the most appropriate because the line graph shows what is called continuous data. Continuous data can have any value within a range, just as how percentages may have any values between 0 and 100. The bar graph is more appropriate for discrete data. Discrete data can only have specific values within a range. The separation of the bars of a bar graph testifies of this fact and also shows that there is no special continuity between the bars. This is not necessarily the best way to depict percentages. So when you are going to use percentages, just using bars that are separated is not necessarily the best way to show that, because percentages is represented by continuous data. A pictograph is also used to represent discrete data. This makes use of small symbols, all of the same size, that are used to represent a large number of items. One will be seen in the next question. So when we are going to be answering number 69, we are going to see a pictograph. Now we are going to be looking at some of the stuff. We have a double bar graph right there. And of course the blues represent the girls and the purple or brick red represent the boys. So here we have them. These blue, all the blue bars are for the girls, and all the others are for the boys. And we have the different subject areas shown right there. So there we have a double bar graph showing the scores of the boys and girls in different subjects. The key shows what color bar belongs to each. The discrete nature of the bar graph may not be entirely inappropriate, as different subjects are not numerically related to each other and should be kept separate. And of course, as previously stated, a line graph with multiple lines would have been appropriate. Different color lines show the different categories, boys and girls. This is also shown in the key. The line graph is shown to be very useful, and one can easily see that the boys score consistently higher than the girls, with the exception of signs in which the scores are basically the same. Notice that the line representing the boys' scores is always above the one that represents the girls' scores. And there you have our pie chart. As expected, a pie chart cannot show two categories of information at the same time. The girls' information is therefore depicted. Another pie would have to be used for the boys' information. The key shows the color related to the different subject areas. It is absurd to use two charts to represent one set of data, especially when one will suffice or even do a better job. Only Jerry Lewis will attempt to use a pictograph to represent the data given. Jerry is saying that is not funny. Number 69, of course. The pictograph shows the number of churches in 4 of the parishes in the county of Cornwall. How many churches are in Hanover? Each little church represents 20 churches. There we have the key. Hanover has 5 little churches. There we have Hanover, and we have 1, 2, 3, 4, 5, right? 5 little churches. So 5 multiplied by 20. Why? Because each little church is representing 20 churches. So 5 times 20 is equal to 100. So the correct answer is therefore option C. The pictograph, this is the same one that we have used for number 69, we are going to be using for number 70. Find the difference between the number of little churches in the specific rows of the table, because that question is saying how many more churches are in St. James than those that are in Westmoreland. So we are going to look for St. James and Westmoreland, and we are going to find the difference between these. So let's see. St. James has 11 little churches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct. Westmoreland has 5 little churches. 1, 2, 3, 4, 5. 11 minus 5 is equal to 6. So the difference between those will be what? 6 little churches. But the 6 little churches will represent what? 20 churches each. So find the number represented by 6 little churches. 6 multiplied by 20 is equal to 120. So the answer is option B. We could have taken the approach that is outlined here, and in that approach we may take what? The number of little churches associated with St. James, which is 11, and multiplying it by 20, we get 220. Then we take the number of little churches associated with Westmoreland, and that is 5, and we multiply 5 by 20, and we get 100. Then what do? We take 100 from 220, and the answer is going to be 120. It is basically what we have right there. However, in mathematics, we have to learn a little rule. Always keep your numbers small. So don't start your problem by using the large numbers. That's not necessary. Start your problem by going with the small. Only get your numbers large when it is unavoidable. And number 71 is based on our same pictograph. To answer this question, find the total number of little churches and multiply it by the number of actual churches that it represents. And of course, what is this problem saying? How many churches are represented? That is overall. So we need to count all of those, and then we'll be able to tell. So in all, we have 30 little churches, and each one is representing 20 churches. So 30 multiplied by 20, 600 churches. The correct answer is D. We are finished with our pictograph. I hope you realize why it could not have been used to represent the data given in question number 68. So Jerry, you thought that I would have forgotten all about question number 68? No, Jerry, I did not forget. See, I've included that in question number 71 also. The graph shows the number of children that attended camp for the 4 weeks in July 2008. How many students attended camp in week 4? Of course, right there you have week 4, Jerry. Just look at it, take the note of the height of the bar, 250, option B. To answer the question, we may just look at the bar for week 4 and take note of its height as indicated on the scale to the left, as we have just said. So that is the bar, and the height of it goes over there. The answer is 250, and it is represented by option B. The graph shows the number of children that attended camp. So it's the same problem that we have, same graph, but we are going to ask another question. In which week did the least number of children attended camp? Close your eyes, Jerry. The only reason you should not be able to answer that question is if your eyes are closed. Because, of course, the week that depicts the least number of children would have the one with the shortest bar. And that is going to be week 1. Camp no warm up yet. We are able to look at the graph and identify the week in which the smallest number of children attended camp. However, we will show this beyond the shadow of a doubt. Construct a table in which each week is shown with the number of children that attend. So, we have the week here and the attendance there. So, identify the number that attended in week 1, 150. Week 2, 200. Week 3, 300. And week 4, 250. So the one with the smallest number, as we can see here, is week 1. And that is represented by option D. How do you calculate the mean number of children that attended camp each week? So how do we find the mean? The mean of a number of entries is equal to what? The sum of entries divided by the number of entries. So it may be written as a fraction for clarity. So the mean is what? Sum of entries over the number of entries. The entries are the weekly numbers, so find the sum of the weekly numbers. The number of entries is equal to the number of weeks. The resulting fraction is expressed by what? Sum of the weekly numbers divided by number of weeks. And which one is that? Option A. So we're going to add the weekly numbers and then divide by the number of weeks. The chart shows the sale of souvenirs in 4 shops of the Montego Bay Craft Market. Which shop sold the most souvenirs? Of course, we can see that easily, Jerry, the one with the tallest bar. To find the shop that sold the most souvenir, look for the one that is associated with the highest bar. That one. So that is what? Shop number 3. That is the answer that has the highest bar. The answer is therefore option B. And we have the same situation with the craft market, and of course we have the same chart. To find the total, add the number of souvenirs sold by all of the shops. Because the problem is saying that what is the total number of souvenirs sold by the 4 shops? So we're going to take them one by one. For the first shop 1, how many did shop 1 sell? 40. What about shop 2? 20. What about shop 3? 60. What about shop 4? Not 70, Jerry. It goes right back down to 30. How do we find the total? We're just going to find the total by adding the numbers that we have right here. So find the total. Total is 150. So 150, and that is represented by option D. So now we have another problem. The table shows the height in centimeters of seedlings in Miss Green garden. What does the height 9 centimeters in the table represent? Well, let us look at it. With the numbers in the height column, which is this one, increasing by 2 each time, there does not seem to be anything special about any of them. See, we have this going up, 2, 7, 9, going up by 2 each time. So, it does not really seem to be anything special. If there is anything special about any of them, it must be related to the accompanying number in the numbers column. Right there. This tells us that the height of 9 centimeters has the largest number of seedlings, or that the height of 9 centimeters occurs the most time. Because see, the largest number that we have here is 20, and is associated with this 9. Right? So 9 centimeters occurs the most time. So in a data set, what do we call the entry that occurs the most time? In a data set, the number that occurs the most time is called the mode. So the correct answer is therefore option D, the mode. And of course, we have the same table, but the question is saying, which statement is false? So, the first statement says that the maximum height is 15 centimeters. Look here. Do we have any height that is greater than 15? No. That statement is true then. The maximum height is 15 centimeters. This one says the range is the difference between the largest and the smallest number in the set. And of course, that is pertaining to option B, because option B is requesting the range. The data is really in the height column. The information in the number column is just telling us the number of each entry in the data column. The smallest height is 15 and the largest is 15. Subtract to find the difference. So 15 minus 5 is equal to 10 centimeters. So that 10 centimeters represents the range. So of course the range is 10 centimeters. So the range is 10 centimeters, and this statement in option B is also true. The minimum height is represented by the smallest number. Of course, we're looking at option C, which says that the minimum height is 15. So the minimum height is represented by the smallest number in the height column. That number turns out to be 15 centimeters. Statement C is also true, because that is the smallest amount, this is the smallest number in the height column. So the minimum height is 5 centimeters. So that statement is also true. The number of seedlings, of course, we're looking at option D. The total number of seedlings is equal to 20. But we know that the total number of seedlings cannot be equal to 20, because right here we have 20 seedlings. We have 20 seedlings, and here we have another 12 and another 4. Another 12 and another 4. Here we have 15, 10, and 5. So we are sure that the total number of seedlings cannot be equal to 20. So we are sure that that statement is false. But the problem is saying that we should find a statement that is false. So that is statement D. Even if we did not have a row with 20 seedlings, an additional row with other numbers of seedlings, we could have added all the items in the numbers column in order to determine the actual number of seedlings, and we would be able to tell if the total number of seedlings is equal to 20 or not. So we have now 60 buns were to be eaten in the shortest possible time by 4 boys. The pie chart shows the proportions eaten. So we have 60 buns to be eaten by 4 boys, and that information is depicted in the pie chart. What is the number of buns that were eaten by Mighty Mouth? It is clear from the pie chart that Mighty Mouth is responsible for half of the number of buns eaten. He is a Mighty Mouth man indeed. A half of 60 is equal to 30. Option A is correct. A half of 60 is equal to 60 divided by 2, which is equal to 30. No problem with that. We may also say that half of 60 is equal to 60 multiplied by a half. So irrespective of how we look at it, the answer is going to be 30, and that is option A. There we have the thing being placed under the microscope. 60 multiplied by a half, we are reducing by 2. 2 into 2, 1. 2 into 60, 30. Like that. So we have 1 multiplied by 30, or 30 multiplied by 1, which is 30, and 1 multiplied by 1, which is 1. So in all, 30 divided by 1, and that is equal to 30. We have the same problem, but the final question is, what percentage of the number of buns were eaten by Chew Fine? We know from the answer to the previous question that half of the number of buns was eaten by Mighty Mouth. This means that half of the total number is left for the other contestants. We can identify the special way that the angle is marked. We know it to be 90 degrees. Therefore, the angle associated or assigned to Chew Fine is also 90 degrees. So here, 90 degrees over this side is associated to Goat Kid, and JF mils. Therefore, over on this side, we are going to have 90 degrees remaining. See, that's 90 degrees on that side for the combined effort of Goat Kid and JF mils. This 90 degrees is out of the total angle of the pi. The total angle is 360 degrees. This 90 degrees out of 360 degrees should be multiplied by 100 in order to find the percentage. So 90 over 360 multiplied by 100 over 1. And of course, 90 will go into 91 times, and 90 into 360 4 times. And that is what we have right here. And then 4 may go into 4 one time, and 4 into 125 times. There. So we have what? 25 over 1, which is 25%. So we have come to the end of solution of practice paper number 2, and I hope that you have enjoyed it as much as Jerry Lewis did, and that you have found it informative. Feel free to watch this video over and over and over again. And if you get this one some good time before the exam, make sure you get practice paper number 3 also in good time before the exam, because these videos will not be of any use to you the day before the exam. The answer is 25%, and this is going to be represented by option D right there.